This presentation will discuss the importance of calculating the business value of information technology. It is extremely important to evaluate the business value of information technology because instituting information technology is very expensive, and many businesses are experiencing failure when doing so. For example, Hershey Foods lost $120 million in sales due to incompatible software. Hershey's failed IT program is not a rare occurrence. It is estimated that $130 billion has been wasted by firms in the United States on information technology. These problems are due to incorrect calculations rather than errors by individuals. Therefore, the process in which business value of information technology is calculated must be reformed. The current approach requires speculation, which often leads to overvaluing IT. Alternatively, the new approach relies on objective data to provide a more accurate value of information technology. In order to demonstrate the new approach for calculating business value of IT, we will be using data from VISTA. VISTA, the Veterans Health Information System and Technology Architecture, is an electronic health information system used by the Veterans Healthcare System. The system provides primary and specialized care to the United States veterans and is the largest healthcare system in the United States. VISTA dates back to the 1970s, and by 1999, VISTA was installed in every VA facility in the United States. In 2006, this system reached 5.4 million patients. This chart represents the data provided on October 16, 2007 from the Department of Veterans Affairs. The data spans from 1998 to 2004 and includes the number of records in VISTA, the cost per patient index, and the Veterans Affairs budget for information technology. In order to analyze the data, we have created scatter plots of the information to show the correlation between the different variables. A correlation close to 1 represents a strong relationship between the two sets of information. This figure shows the relationship between the number of records in VISTA and the IT budget. The correlation is the square root of r squared, which in this case is 0.76. This represents a significant relationship between the two variables. This scatter plot illustrates the relationship between cost per patient and the IT budget. The correlation is 0.89, which shows that the relationship between the two is very significant. The final graph represents the relationship between the use of VISTA and the cost index per patient. The correlation is 0.57, which is somewhat significant but considerably less than the correlations of the other scatter plots. Since we have already determined the correlations, we can now find causation. We will determine if an increase in the IT budget leads to increased use, which leads to a decrease in cost per patient, or if a decrease in the cost per patient leads to increased IT investment, which then leads to an increase in use. To find causation, the equations below must be used. You can put in the correlations from the scatter plots, and the result that is closest to 0 determines the correct causation. The result to the first equation equals 0.4568, and the result for the second equation is negative 0.1064. Therefore, the second equation represents the causation. The method that has been illustrated has a few limitations. For example, the data that is needed is not always available. In addition, using only 3 data groups can be limiting. Although some limitations do exist, the findings of the analysis illustrate that a decreased cost per patient has led to an increased IT investment, which has led to an increased use of the VISTA program at the Department of Veterans Affairs.